Venn diagrams. Venn diagrams were invented by John Venn in the 1880s to depict sets. Each set is represented by a shape, usually a circle, but sometimes squares or rectangles. Elements are indicated by points. For example, if the universal set that we're dealing with is the set of all animals, and M is the set of all monkeys, and H is the set of all human beings, and B is the set of all young boys, and S is the set of all animals that can speak, then our Venn diagram might look like this. Usually you have a big rectangle, and that is your universal set. Everything goes on inside the universal set because that is all that we are dealing with. That is what we consider everything. Let's see M. M is a circle. These are all the monkeys. They are some of the animals, and everything in here is a monkey. Everything outside of here is not a monkey. Human beings. All human beings are non-monkeys, so there's no overlap. If there were some things that were monkeys and human beings, these shapes would have to overlap, but they don't. They're what we call disjoint. Now, all boys are human beings, all young boys. And so the set of all boys is entirely contained within the set of all human beings. It's a subset. Now let's see. Animals that can speak, that one gets a little bit crazy. We'll have to do something like this. We have to have a certain kind of overlap. We have to say, well, what do I mean by this? Well, this point over here is in the set of all boys, but not in the set of all animals that can speak. What is that? That is a mute boy. That is a boy who's not able to speak. That happens. Over here, you'd have either a human, an adult that couldn't speak, or a girl that couldn't speak. In here, you have non-boy humans that can speak. In here are all the boys who can speak. And out here, what's out here? Well, parrots. Those are in the set of all animals, but they are capable of speaking, but they're outside of humans. They're non-human speaking animals. And something out here is something that's neither speaking, nor a monkey, nor human, like a rhinoceros. This is a Venn diagram. Now, Venn diagrams can also be used to depict the set operations, and sometimes they help give a visual picture to these things. For example, this set. We have sort of the universal set. We have set A, set B. We've shaded in the things that are in A and in B at the same time. That is the set of A intersect B. The intersection is where they overlap, things that are in both sets. Now in this set, we have everything in A and everything in B shaded. That is the union. A union B has been shaded in. If you have something like this, if you look really closely, we have everything that except the things in A. That's a complement has been shaded. Now another cool thing that you can do about this, you can use this to illustrate relationships. Now in my upper level math classes I say that these don't count as proofs, but in a math for liberal arts class this definitely counts as a proof. Let's look at this. We have the sets A, B, and C. This is the standard form for the Venn diagram of three objects. We have the possibility of A and B overlapping, B and C overlapping, A and C overlapping, and this thing in the middle is things that belong to all three. Anyway, we've shaded in all of A here. Now over here we've shaded in B union C. And if we take the intersection of these, you get this thing. This shaded in green stuff is in the red and in the blue. And so that is A intersected with B union C. But there's another way to get that same shaded green area. We could have started with A intersect B and gotten these two bits. That's just the stuff that are in A and B. We could also have A intersect C, all the stuff that's in A and C. And if we take this blue stuff and this red stuff and unite them, we will get that. Put those together, A intersect B union A intersect C is the same thing. You get the same shape. And this is one of the logical identities of sets. That A intersected with the union of two things is the same thing as the union of A intersected with each of them individually. I'm not going to expect you to memorize this, but it is nice if you can at least appreciate how Venn diagrams can be used to illustrate things.